So thank you very much for this opportunity. I'm here today to talk to you about some of the outputs from the UK Autodrive programme, which you heard mentioned earlier today, which is coming to completion this month, he says, which is very nice. These are some of its cybersecurity contents. I'll show how quickly I can get through slides. These are some of its, or these are its consortium members, I believe. This is me. I'm a security expert. If you want to read about me, I'm there and all that kind of stuff. And I'm going to emphasise that in the face of a cyber attack, your vehicle and the system that it's part of will fail, because my basic position is anything can be broken, and we pretty much will break these sorts of things. So if we start from that, I'll try and give you some of the confusion things and try and talk about some conclusions and the implications for legal, insurance and public policy. I'm trying to avoid talking about just the technology that goes with this stuff, because very often cybersecurity actually spills over into other things. Existing technical and standardisation approaches, and I really have to thank my previous two speakers here, but particularly their ability to deliver outcomes of resilience and survivability, which I think is really important and increasingly has dominated the vocabulary rather than cybersecurity, and some future avenues for exploration, which we are suggesting need to be looked at going forward. Just to put up on the right-hand side, this was what I was originally asked to look at. So essentially, I had vehicle-to-vehicle communications to look at. We had 3 vehicles, 3 manufacturers. I was capable of crashing any one of their systems from any one of the other systems in different ways. This had nothing to do with their incorrect implementations, which it wasn't, nor with the fact that the standard was incorrect. They simply didn't jive with each other particularly well. Which obviously brought home with some clarity that essentially I don't get to look at other people's stuff, and even people doing the right things are often attacking me without knowing it, which actually comes to be quite a big deal when I'm talking about how my vehicle works. I don't control everybody else's vehicle, much as I may wish to do so. So we extended this in order to look at as well as the pod manufacturer. We also looked at contacts in further 8 OEMs, Tier 1s, Tier 2s, and in adjacent industries to look at what they were doing around these sorts of things. And we came up with these sorts of things. So what is an automotive system? We said it's connected and autonomous cars, but particularly connected in the first place, are a part of a complex, hyper-connected, bottom-up system with emergent properties for which there's no guiding mind. So completely unlike an aircraft, which is a top-down designed, or a nuclear power station or a train, all of which we get to design, which is pretty much what we've done for the last 50 years. So we are actually introducing things that we have not done before and expecting to come out with a good outcome. It's also a system that yields its benefits at scale. So actually we get what we want because all of the cars on the road become automatic, or all of these, not because one becomes automatic. So this is actually quite significant. We can reduce the number of accidents, all the things that everybody talks about. These benefits come from scale. And yet what we know is how to engineer small components. It's a bit of a problem. It's price sensitive, worldwide, and mobile, and has vast amounts of data. I sat in this room 2-3 years ago and listened to my colleagues from NXP tell me about 103 exabytes of data a day being generated by the automotive system. And I'm pretty sure if somebody generates 103 exabytes of data, somebody wants to make money out of it. And I'm sure it's more than that now. It's owned by no one, so there isn't actually somebody at the top end of this that's saying this is what we want to do. You know, that just isn't an option. We did actually do a presentation at the Internet of Things Security Foundation last year. We had our hands up in the room. There were about 100 people, I think, in the room at the time. One thought that there might be somebody that was in a position to say what this system should do, and they thought Google might be able to position to do that, but they didn't think they were interested in doing so. So we've concluded that no one is able to do that. And it's got both strict and contract liability, so I can write contracts around what I'm supposed to be doing in here, but essentially if I kill people, I don't get to write a contract that says that's nothing to do with me. Yeah, you get prosecuted anyway. And they must coexist in this system. And it's multi-vendor, legal obligations, not to exclude suppliers from the supply chain, even though sometimes we do, and increasingly integrated with global information and management networks. Yeah, and our observation is that cyber attacks systematically downgrade the strength of mechanisms, and at the same time they change the probability of exposure. So you don't get something that's static, you get things that are actually being downgraded as you go along. And there's no option to control the global attack surface. I don't get to say, I'd rather you didn't attack me here, or I'm going to construct this in this way. So a lot of the things that we have used over the last 50, 60 years to control our systems and to make it possible to defend them don't really come out as options in this system that we're developing. And I hope you recognise that system, because certainly that seems to be the one that we're working into. I also felt that we should try and put together a 2-line definition of what we meant by cybersecurity, so it's there at the top of the page. It's not copyright, you can use it wherever you want to. Yeah, a connected and autonomous car capability will be cyber safe if and only if we have justifiable. So that goes back to the previous speaker. And enduring, so not just today, but over the next 30 years. Confidence that they will do what we expect, when we expect it. So it's much better than the 20-odd pages of the government cyber strategy. You can remember that one, though theirs is actually a really good cyber strategy, I have to say. But that's the kind of thing I think you're looking for. That is my definition of what we're looking at. That is the one that the Auto Drive Consortium has actually gone with on that one. So just to amplify some of that, a directed attack at the time of attackers choosing against the digital, physical or people of a system in order to have an effect. Only small proportions of what you're looking at on a cyber attack are necessarily anything to do with the technology. It's a really important aspect. We do not have models that allow us to model. I mean, you heard in the previous one how difficult it is just to model the technology, and I'm trying to say you have to model all of these things together. You may get collateral effects being done. So all of you will remember the Jeep attack, Miller and Vasek. What I thought was really interesting in relation, anybody that doesn't? No, jolly good. Yeah. What I thought was really interesting was their observation at Black Hat in 2017. It took us 6 months to specialise that down from an attack against every Jeep to against a single Jeep. So what that's actually saying is, as opposed to electromechanical systems which fail a single vehicle first, what we do is fail globally first, and only the best attackers can take it down so it causes one of you to fail. Any child will be able to break your systems. And to put that into context, some of the GPS-based attacks that we've been looking at are based on using the Pokemon Go tools to move your time and your location. These are being propagated by 13-year-olds who are really familiar with moving their Pokemon Go collection devices. So these are what you're looking at on cyber attacks. It only requires a single weakness. I think our observations, it's something like 160 faults in 1,000 lines of code, or something that we get down to in automotive stuff, but I only need one of those. So what you're saying is we have no feasible way on any standard that we have by which we can actually get rid of the things that we're actually using to attack it. They're not likely, or indeed don't have to, test components of their attack on the target system. So it's not that you get to find out people trying things out and all those things. I'll try it on something else, because you're using the same thing as other people do, and I just bring it to you when it's working, which essentially is really bad news. And the other thing that we talk about a lot of the time, we talk about the fact that the objective of the attack is actually steal money, do things of this nature. A lot of what we see is not that. What we see is share price attacks, things that are designed to take down the value of a company so that you could buy one. It's a lot easier to buy a capability if you take down their share price. Makes it perfectly viable. Public confidence, or a completely different industry. It just so happened that you're using the same processes as the healthcare. And it'll often rely on your unwillingness to confront the unthinkable. A number of times I've heard people say, no, they'll never do that. But they will, but no, they'll never do that. And that is part of the conclusion. So what needs to be considered in doing a digital defence? I've tried to put up something that you can read, so I've made it bigger. People, physical and digital we've talked about. I like triangles. You can do any part of that in order to attack any part of that. This is what a defence has to look at. This is going to the liability. So if you go to court, what you're going to be discussing is, what is the solution costing? What are the odds of loss with no solution? And what is the loss if disaster strikes? So I will tell you, if you're going to have a situation where 40 million cars can be hacked at the same time, at the time of my choosing, you may ask what the solution cost is that you should have been spending in relation to that before you became liable. This, incidentally, was established in the 19th century, so it's pretty well understood by the courts. We are not asking for any rocket science here. And this, to me, is the one, is possibly the novel one coming out of this programme. What are we trying to do? Why do we need to do it? And how are we positioned to make it happen? And I guess to go with Amy's observation at the beginning, how many times I've listened to people talking about very articulately about what they are trying to do, why they need to do it, and with absolutely no idea how the environment could occur that would make that possible, is staggering. And we really do need to think about, as an industry, if we don't know that, then we have to adjust the other two, somehow. And I put up alongside that this triangle. This is not my triangle, I have to say, talking about tactics, techniques and procedures. The amount of time I've heard people talking about how they're actually protecting hash values, IP addresses. It's actually tools, capabilities, it's skills that are far more important. They're more important than our attackers, and they're much more important in our defenders. If you do not have the skills to defend things, then it's no good saying I've defended the hash values. So putting this into context, and putting back to what I was talking about at the beginning there, we observed that we can go from the physical thing, so this is my vehicle-to-vehicle communications. I can actually jam the communications. We didn't ever get the digital signatures working because that was too complex. We could do the link on that. We could do the data. But actually, what is most important is actually what's being passed above that. So let me tell you, this is what I talk about. This is what the program talks about. It talks about how does this lot go together. So when you talk about your vehicle, it's connected to those gantries above the motorways. It's connected to satellites. It's connected to GPS. It's connected to traffic lights. It's connected to other vehicles. The malware that's actually causing your accident is not in your vehicle. It's in one that you've had no opportunity to analyse. So when you go to court, your question is, who is the defendant? Who's liable? Who's the plaintiff? What court and where? And it's not a simple question to answer, but it's one that we as technologists actually have to put people in a position to answer. And this actually, I was pleased to see, came out of the first talk, more or less, in a much easier to read manner. It was essentially talking about some security techniques. But what I will ask you to consider, and what we brought out, was that safety, data protection and business advantage all coexist on the same processor, in the same data, on the same vehicle. And they have conflicting objectives. And you can't finesse them away. So there is no way, even if I do every product, every component correctly, that I'm going to have no cyber attacks. Though I do get opportunities to do things differently on public service vehicles and pods, just because of the scale. So what does this mean? What should we be doing? First thing, I think we need to develop an economically viable and contractable cyber security model. We've got OEMs putting 30-year support contracts, and it's making their suppliers vulnerable. All I have to do is say that I've been attacking you, have you keep patching things, and you will go out of business, because there's no money associated with this. And we need to correct this by putting in place cyber assurance that's based not on data theft, but on the fact that 5% of our supply chain is actually going to be attacked in this way. Otherwise, OEMs will find that people have disappeared. Address the value of data. It's really valuable. There is no way that I'm actually going to bring my data to the point of an accident. And if you're talking about a training data set for a machine learning algorithm, it's not in the vehicle. For the first time, we can't actually do forensics. There's nothing there to do it on. And the impossible for an OEM to contract for a cyber safe system. Even if you do so, it will just come back to you. Here's my bit on machine learning algorithms. Measure and certify expertise. You need to make sure we find a way of actually saying this organisation, this individual, these people actually know what they're talking about. Because if they don't, it's only by accident that they're going to be protecting you. And most particularly, if the key individual, if the key capability leaves a company, that incidentally is a real-time attack on a data classification algorithm based on a single data poisoning point. And if they don't, and somebody leaves a company, for instance, or a company no longer has a capability, why would you contract with them? And that you have to understand across the entire cybersecurity waterfront. Using implementation techniques that impact the digital failure, randomization of algorithms, things of this nature. If we continue to do everything the same, then when it does fail, it will be a catastrophic failure. If everything is absolutely the same the whole time. I've tried to put up there an indication. I normally put up castles and things of this nature to make it clear. But essentially, this is what we do. We analyse things. We do it according to whatever standard it is you want to do things. We have absolutely no evidence that that will work at the end of the day. Indeed, what we have is evidence that it will not work at the end of the day. It has never worked in 1,000 years. And what we then go is say, that's fine, we'll make it much more complex, and yet somehow that will work. So I suggest you need to think about those kinds of things. So if you say we are going to fail, if what I had said on the first slide, that I am going to be able to successfully attack you, is correct, then you need to consider not that we fail, but how we fail. That is a much more important consideration. We need to change our vocabulary to start talking about those sorts of things. And I think pattern of life and forensics, rather than some of the more classical cryptographic methods, things like attestation, things like being able to detect that a lens in a sensor with the software that's supposed to be sitting behind it could not have delivered the image that it says. It's not capable of doing so. That kind of partially complete set of things are the sort of thing that you need to work on, and we need to start to get standard around those. Clarify liability to remove conflict between system and component. One of the key observations is that since we understand how to do components, your OEMs, your tier ones, your tier two, everybody will concentrate on doing the things they are legally liable for doing, and the output will be disastrous. What we actually have to do is get some, and as an industry, start to talk to government about how we might need a clarification in the law, so that protecting the system that you are part of, and which will now catastrophically fail, is one of the considerations you can bring to court. Because as you saw previously, that is not currently one of the arguments that you could reasonably bring. So this was just designed to ask those kind of questions. But one of the most important things, there are some really sacred cows that we have here, things like type approval, things like V&V. These have served us well in the past, but actually what they're doing is constructing a system that works identically. I love you. I really do if you do that. If it takes you 3 years to work out what it is, I have definitely worked out how to break it long before you get it to market. So from a cyber security point of view, they are a disaster. And we actually know that we are constructing things that will fail. And I challenge you to be comfortable taking that to the judge. Recognise the complexity. You've heard it in all of the three speeches here. Being introduced by digital and particularly cryptographic countermeasures. These things make it difficult. If I encrypt something, and I lose the keys, what does that mean? If I've lost my root of trust, what does that mean? It's not a failure in the way that it was when we got a simple electromechanical failure. It's something that now ripples out through the entire system, and it quickly becomes so complex that we know that you can't have analysed the safety. So it's beyond the state of the art to have done those sorts of things. So things that we're trivially being encouraged to put in there by the IT industry actually give you real problems in making the safety cases that you need to do. And understanding its remediation strategy. If you can't fix it, if you can't get out fixes at scale, this is a real problem. And I know we've posed the question, what would it take for the sorts of things that Google uses in its Borg to actually be something you could make as a safety case? What would that mean? Because if we don't start making that kind of argument, we're probably going to be in trouble. And recognise where static techniques are being deployed, they're unlikely to withstand attack. So you'll have heard of quantum computers. So we're putting in place roots of trust that are based on digital signatures that we expect to be compromised within the lifetime of that component. We expect it, and yet we're deploying it. But that's okay, because what we're doing is building more complex chips to do those sorts of things. The point is, we're deploying 30-year capabilities for things that we know will be compromised in 2, 3, 4 or 5 years. That is an extremely rash thing to be doing. So, my summary, almost getting there on time. Delivering a cyber-safe automotive requires actions from legal, insurance and public policy as well as the industry. It's not just a question that we do this. There are things in the way that you prosecute, there are things from insurance that need to be adjusted in order to get us up, and could be done easily, and will give you a much better position. But you guys need to ask for it altogether. It's not something that, you shouldn't be embarrassed about asking for these things. It's not because you're trying to do a bad job. existing technical and standardisation process, they must be adapted. There are some really good things that we do, and we shouldn't get rid of the state of knowledge that we have, but we need to use them in different ways, and we need to understand they are not going to give us the certainty that we have previously relied on. And some of the areas of research and engineering practice are as yet immature. So things like the machine learning and how you do things, they are not at a state where you could use them and take them to court. We need to mature these very rapidly.